$19 billion. That is the staggering price tag to save a city from total transport gridlock. We are standing over the most complex construction site in Australia, the Cross River Rail in Brisbane. Down below, two 1,350-ton colossal tunnel boring machines have carved a path through solid rock. This 10.2-kilometre rail line is a precision strike through the city's dense urban core, featuring 5.9 kilometres of twin tunnels that plunge deep beneath the Brisbane River. We are talking about an excavation so deep it shattered every previous record in the city's history. But with costs tripling and the opening date sliding years into the future, the pressure is higher than ever. How do you dig a tunnel beneath a major river and through a forest of skyscrapers without the entire city above collapsing into chaos? To understand that, we have to look at how the city was built decades ago. Since 1978, every single train coming from the south had to cross the Merivale Bridge. It was the only way to get into the city centre. Imagine a giant funnel where every train in the region is forced through one tiny neck. If a single train broke down on that bridge, the entire city's rail system would stop working. Engineers call this a bottleneck, and for Brisbane, it was a disaster waiting to happen. By 2016, the bridge was almost completely full. Experts realised that by 2026, the trains would be so crowded that people wouldn't even be able to get on them. The population was growing fast, and the number of people needing a seat was expected to triple by 2036. The city was basically out of space, and building more roads just meant more cars stuck in traffic. The only way to grow was to go down. They needed a second path through the city core that didn't rely on that one old bridge. The history explains why we need it, but it doesn't explain the sheer power of the machines doing the work. Meet Elsie and Merle. These are the two massive tunnel boring machines, or TBMs, used to chew through Brisbane's rock. Each one is 165 metres long. That is longer than a football field. At the very front is a giant spinning drill called a cutter head. This drill is 7.2 metres wide and weighs 120 tonnes. It's covered in heavy metal discs that roll against the rock and crush it into small pieces. While the front is drilling, the rest of the machine is like a moving factory. As it moves forward, it pulls the crushed rock onto a conveyor belt to send it out of the tunnel. But here is the really cool part. While it drills, it also builds the tunnel walls. The machine uses giant mechanical arms to pick up curved pieces of concrete called segments. Each segment weighs 4.2 tonnes. They fit 6 of these together to make a perfect circle. Over the course of the project, these machines installed 25,000 of these concrete rings. They moved at a speed of about 40 metres every day, working 24 hours a day, 7 days a week. Those metal giants are impressive. But the real nightmare wasn't the dirt. It was the water. Imagine digging a tunnel while a massive river sits right above your head. This was the most dangerous part of the whole job. When TBM Elsie started digging under the Brisbane River, she was 42 metres below the water's surface. At her deepest point at Kangaroo Point, she was 58 metres down. The pressure from all that water and rock is immense. To keep the river from leaking in, the engineers used a double shield design on the machines. This means the machine is wrapped in a hard metal shell that protects the workers and the tunnel while the concrete walls are being put in place. They also used a special technique called probe drilling. This involves drilling small holes far in front of the giant machine to see what kind of rock is coming up. If they found a crack or soft ground, they could fix it before the big drill ever touched it. This ensured the tunnels stayed completely watertight. Escaping the river was a win, but then the engineers hit the city. How do you dig a hole 15 stories deep right next to giant skyscrapers without making them fall over? This brings us to Albert Street. This is the site of the deepest hole ever dug in Brisbane. It is 50 metres deep. To give you an idea of how big that is, if you put a 15-storey building inside the hole, the roof wouldn't even reach the street level. Because the space was so tight between tall buildings, they couldn't just use a big digger. They used machines called road headers. A road header looks like a giant mechanical dinosaur with a spinning pineapple head covered in metal spikes. It can chew through 60 tons of rock every hour. This allowed them to carve out a massive cavern for the station platforms that is 290 metres long. They even used a special jump form method to build the station. This is where the concrete forms actually jump up to the next level as soon as the floor below is dry. allowing them to build the station from the bottom up very quickly. While they were digging these massive holes, they had to be extremely careful about the buildings already standing there. When the tunnel had to pass right under the Roma Street busway, the engineers faced a massive challenge. The tunnel was going to be only 15 meters below the foundations of a busy bridge where buses are driving every minute. If the ground moved even a little bit, the bridge could crack. To solve this, they used a trick called underpinning. They built new tiny foundations called micropiles to hold up the bridge. Then, they put a steel collar around the bridge's columns and used hydraulic jacks. These jacks could actually lift or lower the bridge by tiny amounts in real time. If the TBM digging underneath caused the ground to sink by even a few millimeters, the sensors would tell the jacks to push the bridge back up. This let the buses keep running 24 hours a day, while a giant drill was literally passing right under their wheels. But the engineering isn't just about the big machines and deep holes. Sometimes it's about the small things you can't even see. Above the site where they were blasting rock for the Albert Street station, there were old sewer pipes. If those pipes broke from the vibration of the explosions, it would be a smelly disaster for the whole city. Since they couldn't turn off the sewers, they had to fix them while they were still full. They used a special plastic liner that they could slide into the pipes at night. This liner was strong enough to protect the pipes from the shaking ground. This kept the city's water and waste moving, while the heavy construction continued just meters away. We've talked about the physical tunnels, but what about the control system that keeps these trains from ever colliding? It's called ETCS, the European Train Control System. Right now, Brisbane relies on traditional coloured signals mounted beside the tracks to tell drivers when to stop. But once trains disappear into deep underground tunnels, that system simply isn't good enough. ETCS is a digital control system that communicates with trains using radio signals and small trackside beacons known as balises. It knows exactly where every train is, how fast it's travelling, and precisely when it needs to slow down. Because the system tracks each train's exact position, massive safety gaps are no longer necessary. This is the key to doubling the city's rail capacity. With this control system in place, Brisbane can run 24 trains every hour in each direction. That's one train every 2.5 minutes. The result is a true turn-up-and-go network, comparable to subway systems in cities like London or New York. The engineering is world-class, but as they dug into the future, they accidentally stumbled upon a dark secret from Brisbane's past. When the crews were digging at Albert Street, they found themselves in an area once known as Frog's Hollow. In the late 1800s, this area was a swampy fringe of the city that evolved into Brisbane's first Chinatown and a notorious red light district. Before the massive machines could move in, archaeologists were brought in to excavate the ground. What they uncovered was a time capsule buried for more than a century, thousands of artifacts hidden in the soil, old coins, worn leather boots, even tiny needles once used in opium dens. Silent traces of a forgotten underground world. One of the most amazing finds was a set of paw prints in a piece of concrete from the 1880s. A little dog had run across the wet floor of a shop over 140 years ago, and its tracks were frozen in time until the rail crews found them. These discoveries give us a rare look at what life was like for the people who lived in these swampy streets before the skyscrapers were built. Even with all this amazing technology, building a project this big isn't easy. The Cross River Rail has run into some very big hurdles. Originally, the government said the whole project would cost $5.4 billion and be finished by 2024. But as they started digging and hit tough rock and complicated underwater sections, the price started to climb. By 2024, the total cost reached over a massive $19 billion. That is more than 3 times the original price. Part of the reason for the jump in cost was that they had to include things they didn't count at first, like $5 billion, just to connect the new tunnels to the old tracks and build places to park the new trains. There were also over 140 days where work had to stop because of arguments between the workers and the builders. Because of these delays and the long time it takes to test the new digital signalling system, the first passengers won't actually get to ride the trains until 2029. Once the tunnels are finished, they have to spend 2 whole years just testing everything to make sure it is 100% safe. This project is the biggest thing to happen to Brisbane since the first tracks were laid over a century ago. It is the key to making sure the city is ready for the 2032 Olympic Games. By creating two separate paths through the city, a problem on one line won't stop the whole network anymore. It changes the way the entire region moves, from the Gold Coast all the way up to the Sunshine Coast. If you enjoyed learning about how engineers are literally moving the earth to change this city, make sure to hit that like button. It really helps the channel out. Subscribe and turn on those notifications so you don't miss our next deep dive into the world's greatest engineering marvels. What do you think about the $19 billion price tag? Is it worth it for the future of the city? Let us know in the comments below. Thanks for watching, and see you in the next one.